Hello everyone, Assalamu alaikum. In this mini project 5, you will understand how to control LED brightness using a potentiometer. So let's get started. First of all, download the link. I uploaded down there, or you can find the file on LMS. So let's go to project 5. So here we go, LED brightness control using a potentiometer. So what is the aim of this project? This mini project aims to show you how to control the state of digital output device such as LEDs using analog input devices such as potentiometers. To do so, you will use the Arduino functions analogWrite and analogRead. In this project, you will control the brightness of an LED using a potentiometer. So what will be the project outcomes? The analogRead to read the voltage from the potentiometer, and the analogWrite to control the brightness of an LED. So let's go to Tinkercad, circuits, create new circuits. So this is the usual steps here. We do it in every project. And then here, click on Arduino. And then let's find a project using a potentiometer. So drag this one, analog input, drag this one here. So as you can see, this is a potentiometer. This one is connected to the analog inputs here. And of course, any electronic you have to connect it to the ground. And this is for the voltage. Okay, so the analog input here is connected to pin number 0. Now let's go and check the question here. So what do we need? We need a potentiometer, jumper wires, breadboard, Arduino LED, and a resistor. So as you can see here, no need to use the breadboard. I already dragged a ready circuit with a potentiometer, right? So I need only to use or to add LEDs here, LED and a resistor. So this step here is done for us. Now I need to add LED. So where to add the LED? So let's go to our code. So you can copy this code and paste it, or you can go from the same file. So then go to mini project 5 and then click on OK, and then copy. So Control A and then copy, or Control C. Then go to the code here, delete everything, and copy your new code here. So as you can see, the potentiometer here is connected to A2. So just click on the wire here, and then the circle will appear, then move from A0 till A2. Okay, and then here is the LED is connected to pin number 9. So let's go and insert LED. How to do so? Click on code, then go to the Arduino, then click on all. Here you can write LED and drag this one here, and then write resistor, and drag it here. So let's go to the code here. So the resistor is 220 ohm. So take it, put it here. So the LED is connected to pin number 9. So go to 9 and put the LED direct here, and connect your LED direct to this. Now this one should be connected to the ground. So go there and then click like this, and then go to the ground. So here is the connection for the LED. One should be connected to the ground and one should be connected to the pin number 9. So let's start the simulation here and see what will happen. As you can see here, there is light within the LED, but the light is not in its minimum or its maximum. Why? Because as you can see here, the potentiometer is in the middle. So let's go clockwise So as you can see, the LED is go to its maximum brightness, then go and move this to be anti-clockwise. So anti-clockwise decrease, clockwise increase. Okay, so let's stop simulation and let's go to the first question here. Observe the effect of turning the knob of the potentiometer clockwise. Does it increase or decrease the brightness of the LED? So as you can see here, when we put it clockwise, it was increasing. Okay, now let's go to the second question. Disconnect the potentiometer power wires that are connected to 5V and ground and connect them again, but swap their positions. Turn the potentiometer knob clockwise and then see the result. Does that increase or decrease the brightness of the LED, and why? So swap this one, put it here, and this one, put it in the 5V. Okay, so here we swap their position. Now let's start the simulation and see what will happen. So as you can see here, when we go clockwise it's decreasing, and when we go anti-clockwise is increasing. So when we swap the 5V and the ground, also the opposite happen here. See, here is increasing and clockwise decreasing. So why do you think this is happening? So as you can see here, the potentiometer is actually working as a voltage divider. So of course, if you swap the ground and the 5V, if you swap the voltage here, of course the action or the result will be swapped or will be reversed. So now let's move to the last question here. So this is the challenging question. Modify the code so that the potentiometer controls the LED blinking speed instead of controlling its brightness. So to do so, first of all, we need to understand the existed code first. So let's stop the simulation and put this back in its normal place. Here is the 5V and the black one here in the ground, which is this right side. So let's understand the code here. So the first lines here before the setup, we usually define any new variables and we give any connection here a name, and we declare the place where it is connected. So first of all, we declare here the potentiometer. It is connected to A2 and it was connected here in A2. Okay, so the potentiometer here is input. So since it's input, we have to declare new variable to keep this inputs from the potentiometer. And then finally we connect also a pin, LED pin in pin number 9. So we give it a name LED and we equal connected to pin number 9. So 9 is its place. Okay, then to start any code you need to write two main functions, which are void setup and the void loop here. Okay, so in the void setup, if we want to use the serial monitor, we open or we write this code serial.begin and then write the speed here, and also we write the pin mode. So here is the second step as we mentioned. Let's go to the pin mode. So what is the pin mode? In the pin mode we write the pin name, here is the LED, and then we define whether it's output or input. How to decide that? As I told you before, if we are using your hand like a potentiometer or a push button, or there is a sensors coming to the Arduino, so this is inputs. But if you can see the light, hear the voice, see the movement or the motion from the motor, all of those things are considered as output. So for the pin mode here, we have two connections, one for the potentiometer and one for the LED. The existed code, you can see that there is pin mode only for the LED. So why do you think is that? Why they didn't put the pin mode for, why this line was not there? The potentiometer here, and the potentiometer of course is acting as an input. And don't forget, in all in capital letter. So why this line was not there? Because the potentiometer was connected to analog pins here, and the analog pin are acting only like an input, so no need to write this line here. But I will always prefer to write it, so you will put into consideration that potentiometer is input, so it will make the code easier for you. How? Because if the pin mode is output, you need to use the write function, and if the pin mode was input, you need to use the read function here. Okay, so output write, input read. How you cannot forget this information here? So when you go to the exam, you are reading the question, so this is input to you. You study for the exam, so this is input, and then when you go to the exam, you write your question, so this is the output, this is the result, right? So now let's go to the void loop here. So one important thing to remember and to put into consideration while using the read function, when you are using the read function, you need to define a variable and save whatever information comes to read function into this variable. Okay, in this case we have the potentiometer reading. So this potentiometer reading is equal to this analog read function. Analog read of what? Read of the pin connected to pin number A2, which is the potentiometer here. Okay, so we need to declare a variable, whether it's digital or analog, because we need to save this information coming to the Arduino. Where to save it? In a variable, we identify it here and then we use it here. Also, you need to know that the potentiometer here for the analog read, it has a 0, or it has a value from 0 till 1023 is the maximum value for the potentiometer here, and I can show you a proof of what I'm saying here. So in the analogRwrite here, as you can see, you need to put the pin name, which is the LED here, because I am controlling the LED, so the LED, and then comma, and then here I need to put the value. Okay, here the value is 255. This is the maximum value that the analogRwrite can get, 255. Okay, so to see the value of the potentiometer, so now we need to see the value of this potentiometer. How to do so? Let's use the serial dot print ln, so new line, and then let's see the potentiometer reading here. So let's copy this variable and put it here, and then semicolon. Okay, let's see the result here. Start the simulation. Yes, here I forget the P should be in small letter. Yes, only the M only in capital letter. So let's start the simulation. So start the simulation here. So as you can see, the potentiometer here is in its minimum value, so it shows 0, and then when I go clockwise, see the number is increasing till I reach 1023. So this was mentioned there. So in analog read, 123 is the maximum value. Okay, so So since 123 is the maximum value for the potentiometer here, so this value will go to the analogWrite here. But the analogWrite here cannot accept any number above the range of 255. So that's why I divided this number by 4. So to give you a proof, let me open the calculator for you here. So the maximum value for the potentiometer here, as you can see from the serial monitor, is 1023. But the maximum value for the analogWrite is 250. So as you can see here, the number is 4. So if I divide the potentiometer value by 4, I will get the maximum value, which is 255. Okay, so let's clear everything here. So 10323 divided by 4, will it give me 255? Yes, it does give me 255. So that's why I divided this number by 4. Okay, now let's stop the simulation. Also here, so you can see it yourself, if you divide here by 4, you will see the maximum value here, 255. That's why we divide the number here by 4. So that's it for understanding the code. Now let's go to the question here. Modify the code so the potentiometer controls the LED blinking speed instead of controlling its brightness. So in this code, we control the brightness, right? So here, this is the maximum brightness, and then this is the middle brightness. Here, there is no brightness, and when I go up, the brightness increased till it go to its max. Now I don't want that. I want this potentiometer to control the speed. So to control the speed, I would always go to the delay function here. So let's clear this and let's see our code here. So I don't want to control the brightness. So if we control the brightness, we use analogRite. If we are not controlling the brightness, so we need to use digital write. Then the LED here, it should be high, and then the semicolon. So I need to use the delay here, the delay, but since I am controlling the speed or the speed of the blinking, slower or faster, I need to change the time here. So what do you think can be here inside the delay function? So instead of putting number every time, there is a reading from the analogRead, right, from the potentiometer. So this reading can be the answer here. Okay, and then I will use the same code for the blinking off. And also the delay should be the result from the potentiometer, taking from the potentiometer. Here is low. Okay, here no need to divide by 4, but I won't use it anyway. So let's run the code, start the simulation. So as you can see here, this is 1023 delay, 1023 millisecond, which is 1 second almost. Okay, so as you can see here, it is slower. Now what if I decrease the value here? If I move this, this will be removed. So as you can see here, it's go faster. Why is this happening? This is happening because simply if you want to go slower, you just increase the time here. If you want to go faster, you just decrease the time. So if I want to go faster, I will just decrease it. So as you can see here, is decreasing faster than ever. So that's it. And then finally, don't forget to change the project name to Mini Project 5, your name, then your class, then click on enter.